So we are going to work on a problem. It's from DeVore, 8th edition, chapter 12, exercise 38. And it asks us, is the following data is representative of that reported in an article, where we have our independent explanatory variable, x, which is a burner area liberation rate, and our response variable, or our dependent variable, y, is the emissions rate. Now, this is copied from WebAssign, so it does have randomized values, the red values. And it wants to know, does a simple linear regression model specify a useful relationship between the two tests? So we want to know if we have a useful relationship. Specifically, because we're doing a linear regression model, we want to know if it's a useful linear relationship. So we want to know if we have a useful linear relationship. And this is the megastat output that I got when I ran it. With just a few things whited out, so you had to do them by hand. So let's go through what we know about doing a test. Okay, so first of all, if we want to know if there's a useful linear relationship, or if there's a significant linear relationship, we are asking about the slope. Okay? Because if our slope is 0, that's when we know we have no relationship. That means if our slope is not 0, then we have a useful linear relationship. Now, the null hypothesis is that the slope is 0, or that there is no relationship, and we want to try and prove that wrong or find evidence against that, hence finding evidence that the slope is not 0 and that we do have a useful linear relationship. Now, it just said it's a useful linear relationship. It didn't ask you if it's positive or negative, so we don't care if the slope is positive or negative. We just want to know, is the slope not 0? So we have our null and alternative hypotheses. Other things you need to do a test is you need to know your test statistic. In our case, our test statistic is equal to the estimate for the slope over the standard error for the estimate of the slope. Okay? Estimate of the slope, standard error for the estimate of the slope. So 1.6988 divided by 0.0883, accounting for any rounding issues, you should be equal to the t-value that is included on your output. So 19.244. That's how you get your test statistic. Then you will also need degrees of freedom, which are equal to the sample size minus 2. Notice I can find my sample size is 14 minus 2, that gives me 12. Or I can notice on the output that the degrees of freedom are 12. So we have 12 degrees of freedom. Next, we look at the p-value. Okay, and to do this, we use our tricks from previous units. So if I have a not equal to alternative hypothesis, I'm interested in the area in both tails. So if my test statistic is 19.244, I want the area in the right tail. And I also want the area to the left of 19.244. So my p-value is 2 times the probability that I get a t-value greater than 19.244. Notice I also have, again, 12 degrees of freedom. So to do this, I could come and look at my t-table. Okay. I want 12 degrees of freedom, and I'm looking for my test statistic of 19, and it's going to be way off here to the right. Okay. Very far off to the right. So small that I think it's going to be about essentially 0. So we could put in essentially 0. Now in WebAssign, you do need more accuracy than the table will give you to get the correct answer. So to do that, we just go online and we look for any t-calculator, just type in t-calculator, see what comes up. So we have 12 degrees of freedom, and our test statistic is 19.244. And I want not just the area to the left of or the area to the right of, but the area in both tails. So let's select area to the right of, compute it, and it shows me that it is 0, and that was just the area in the right tail. So times that by 2 gives me, again, 0, 0, 0, 0. And different calculators will give you even more precise, accurate estimates for the p-value, but this is enough to put into WebAssign that my p-value is 0. Okay, That is a small p-value, so we can reject the null hypothesis. And we have evidence, or the data suggests that there is a useful linear relationship.